Hello, my name is Vandit. I have prepared this video as a part of our project extending Cello to make it more user friendly for generating genetic circuits. Now, for the first 1 or 2 minutes of this video, I'll be giving a brief about our project, and I'll be explaining it in my words. And if you want to skip this part, you can you can jump after 2 minutes, and that is which contains the contribution of my contribution in this project. Cello is a tool for genetic design automation which makes genetic circuits automatically by user provided circuit in form of code hardware descriptive language, that is Verilog. Logisim is a GUI software for making logic based circuits. We are providing a software extension which takes input circuits from generic Logisim GUI and converts that information to Verilog code which is directly usable Cello. A simple GUI based software that helps students to learn and implement electric circuits. Now, but there are some limitations of our currently available version, one of which is the input capability of software, which is only Verilog code in this case. Synthetic biologists generally do not happen to be the practitioner of Verilog, and there could be a more generic and less complex way to provide inputs in the software. If we try to describe the circuit functionality, that is by truth table in Verilog, even for 10 input pins, the code can take more than 1000 lines. So GUI converting generic circuits to Verilog code is essential for Cello. Now the work distribution has been distributed as per the table, and my contribution is indicated by highly selected by red in the red. Now the information regarding the input pins, the output pins, AND gates, OR gates, and the respective connections has been provided priorly to this module, and the order of the connection is also being provided from the module attached before this. Using the order information, the code writes the gate based Verilog code. Sequentially writing the connection information and assigning non-conflicting intermediate output, writing connection information and the node information. Now the module has one output pin and 5 input pins, which is indicated by input 1, input 2, 3, 4 and 5 respectively. Now there are 4 intermediate wires, wire 1, wire 2, wire 3 and wire 4. Now if a OR gate is been used and between two inputs, input 1 and input 5, then the result and the output is stored in the intermediate wire W1. And if AND gate is been used between input 2 and input 3, and the result has been stored and the output has been stored in the intermediate wire W2. And similarly, same case applies for the NOT and the other two AND gates. Now parsing gate based code line by line and then changing it to assign gate based Verilog format. Now each line of the code on the left hand side has been passed into block on the right hand side. Now here the OR operation has been indicated by a line between two inputs, between input 1 and input 5, and the result has been shown in intermediate wire W1. Similarly, the AND operation, which is indicated by ampersand, is operated between two inputs, input 2 and input 3, and the result is been stored in the intermediate wire W2. Same applies for the other NOT operation and the other two AND operations and gates. Now the module here it consists of the truth table based method, which includes one has a model which includes one output and 4 input pins. Now as there are 4 input pins, the 16 different input connections are possible. Now we will make 3 matrices, one input, intermediate outputs and outputs. All the binary strings are spawned from 0 to raised to n-1 in binary form. For each input, each line of code is passed, and then the intermediate output and the outputs are saved in the table. After all the input outputs are initialized for that row, that code goes for the next row, that is the next input. After creating all this information, the truth table based code template is used and the Verilog code is generated. Now in the blocks shown on right side, now the 4 indicates that there are 4 different types of inputs, and the one indicator on the right hand side of the equal to indicates there is only one output. And now it is clear from the block that the output is 1 only when all the input are 1. That's as a result the output is indicated by 1, while all the other outputs are indicated by 0. Now the problems with the implementation of software is that first, the logism circuit file is not structured. It is on canvas, and identifying the underlying circuit just from its code is not trivial. Now we can solve this by using a graph algorithm to find the connection of logical gates from unstructured canvas nodes and make structured information in the code. The second problem is that now Verilog language itself is very structured, and any intermediate nodes used in the code cannot be used without having them on the output side. We can solve this by dynamically extracting the nodes which are evaluated and can be added to Verilog output file. Truth table based Verilog code is generally too long and clumsy, which can produce several errors. Now the solution for this is a simple GUI to overcome this. Fourth, Cello software itself takes too much time to run on moderate size circuits because of its non-deterministic algorithm. We cannot afford cost for extra overhead for GUI. We can solve this by trying to parallelize the whole algorithm. That will be from my side. Thank you.